Assalamu alaikum. I'll try not to delay as much as we have. I'm Abdullah Naaser Naimi from Jamiat Qatar in the Department of Architecture and Urban Planning. So what I'll be talking about basically is a sustainability design method through spatial design. And what I mean by that is there's a difference between technical aspects that you would allow or allocate within your building in order to increase the efficiency, but this one was based on spatial design, and you'll see as I go through the presentation how I got to that. So quickly, I started this with analysis on the built environment and the population within Qatar. So you can see this is West Bay in Qatar 2003. And this is what happened as of 2015. So there was an increase in population and the built environment. Again, here in northern Akhriyat, you can see the development here as well. And then Rawdat Hamama, which is a new jurisdiction, 2006 versus 2015. So basically, this is what this is telling us is there's an expansion in the built environment, and the percentage I found for that was about 330%. So based on some figures I got from Kahrama, the average annual or monthly use in the summer is 13,000 kilowatt hours versus 8,000 in the winter. And if you calculate that, that comes out to per year, as of now, we're using about 4 million megawatts of energy. And if you project that with the expansion growth that we have calculated, you see that we're going up to about 14 million. So what does that mean? In terms of sustainability, you always have this cycle that is represented. And then I would like to present what's happening is we have energy use, which is resulting into climate change. And that is all a component of the population. So the greater the population, the more adverse effects you have. And I would like to call this the unsustainable cycle. And this is currently what's going on because all of our uses in energy are from non-renewable sources. So why is that an issue here in Qatar? Because you can see this is part of so this is the distinction of the desert climate. And one of the thoughts I had was, how did people cope with this early on? And you can see also it's projected within the next coming 50 years that this desert is growing. So that was the issue I wanted to tackle in terms of the social aspect of this, is how it came up to be. So I looked for a precedent to find. And what I came up with was the old historical tent dwellings of the Bedouin people. So basically, kind of looking at the basic elements here, you have a shelter, an enclosure, and the structure. And it would be in the cases that environmentally, they would open it up a little bit in the summer that allowed shade versus, or this would present different typologies of spaces. So you can see you have a semi-interior space and then a semi-exterior space. And then in the winter, there would be introducing the livestock inside as well to maximize the thermal gains inside. And this also introduces a different typology of spaces. So from that idea, I went into classifying the typology of spaces within the vernacular architecture. So you see you get from interior all the way to exterior, and then you have interstitial spaces within that. And then I go through research, defining them in terms of 3D composite or three-dimensional composition of spaces, which I won't talk about much here, but there was research along those aspects. So this is where I came up with this framework of the built environment spatial layers, where you have two zones basically. The existing zone, so there's land that's never been developed, and then there's land that has been developed. And then that developed zone falls into that developed area falls into the design zone, where you have the four distinct spatial typologies. And a quick example of that, I'd like to give you a couple examples. So if you guys walked around Qatar today, you'll see, and if you look at it through this lens, you can see that you have these typologies exist within the built environment. So again, here in the Pearl, you can see interior spaces, semi-interior spaces, and semi-exterior spaces. And again, in Qatar University. So what I'm trying to say here is, in terms of achieving human thermal comfort for the users of the building, there are 6 elements that we gauge. These elements listed here can all be influenced in one way or another through architecture. So basically that came to the conclusion that the more you have, the more possibility, the more matter you are building with, the more the possibility of achieving human thermal comfort is. So this diagram represents that. And the idea of developing this sustainable method was in order to allow for a gauging of sustainability as well as a conscious design before you even go into the design development portion. So you can see in the graph here that through pre-design, I'm trying to access this sustainable methodology or ideology in order to push through design. So I'm just going to take one example here that I did do the research on to prove that this method was effective. So this is a community center in southern Arizona. So this is the initial design. Whenever you're presented with a design as an architect, usually the case is to enclose everything. And this is what I'm trying to go against here. So the program is provided, and this is the initial plot or the initial design. And you have to look at some climatic issues in order to establish if you could, or the percentage you could engage the building without having it overcool or having it too hot or too cold, basically. So my parameters were in working zone, and you can see that, or in this diagram, that this is the area that we're working with. In terms of this is our highest summer and our lowest winter, and we do have sufficient air movement and sun exposure to balance this out. So it's a matter of the environment allows for thermal comfort, you just have to work with that. And again, there's also data that you could run through this simulation here representing the plots of the data points. And you can see that without anything, you have 8% of thermal comfort achieved naturally. So the main areas that I worked with here, so the multifunctional area was one area that I took from the outside, the inside, and moved to the outside. And you can see basically what's happening here in the summer condition is based on the data I showed earlier that we do have 7 miles per hour wind, which is adequate enough to reach human thermal comfort into that space, provided the shading that you are providing. And also in the winter, you do have adequate solar exposure into this area. So this area can become a external area. And then I go through that through the educational space as well, gauging through the users in terms of summer and winter that we can achieve human thermal comfort, and then as well as a fitness area. And part of these areas, the rationale to taking them outside is through the program itself and the users. Some programs you can, since this fitness area, for example, you're already going to be conducting in heavy work, so it might as well, you could move that outside and reduce energy instead of keeping it inside and cooling it. So again, taking that through a summer and winter analysis, and what we kind of come up with is this plot afterwards. After going through the program one by one with the client, picking out the points that you could, or the spaces you could take out, you come to this realization, which is really a sustainable method in terms of the spatial allocations and not through additive measures. You can, at this point, add passive design, high technologies to increase this. So the initial analysis, just to verify this, was conducted through energy use intensities of these spaces listed in this figure, as well as in terms of resources, cost analysis of both range and average costs. So what happens is basically through the calculation analysis, you find that in the first case, we have about $1.2 million in building costs, and then 300,000 kBTU per year in energy use. And then that significantly reduced just by allocating different spatial assembly typologies within the building. And then we take this to verify it into a digital simulation, energy simulation, which I used eQuest here. So comparing the two buildings, we set the parameters, run the system, and then this is what gives you the data. So you can see about 380,000 kBTU per year versus about 190,000 kBTU per year for the second project. So when we compare that, you can see that through the calculation method, throughout simulation, we found that there was a 37.5 reduction in energy use. This is just on papers. But in the simulation, you find more benefits. So about 50% of energy use reduction, and that's just because the spaces kind of tend to shade one another. So there's a dynamic component in this process. And as well, if you take those elements, you push them through in terms of resource consumption and CO2 emissions, there's also those benefits. And then basically, I just want to conclude at this point that this adaptive method is focused on space, so spatial appropriations of the spatial typologies in order to achieve sustainability. It was taken through a precedent of the vernacular architecture, so how these people dwelled back in the day. And it only looks at the energy benefits here, but if you do push it forward, you could easily put it into resource consumption, CO2 emissions, which is a great ideology to push forward the thinkings of, or the thought of green engineering. And so at this point, I'd like to invite you to see the world maybe through different colors and understand these different spatial typologies that do have a conscience, or do have a physical input to the built environment. Thank you very much.